In the hush of the lunar night, where even the faintest whisper of dust seems to drift slowly through the stillness, the story begins as gently as a sigh drifting across an ancient plain. The moon rests in its long, patient silence, wrapped in the pale glow that brushes lightly against its craters and frozen seas. Beneath this calm shimmer, ideas of forgotten traces, old mysteries, and hints of presence weave softly through the emptiness. And as the light settles, the landscape listens, as though it remembers something it has been holding close for eons, waiting for eyes slow enough and hearts quiet enough to hear its tale. The dust beneath this glow lies untouched by winds, because on the moon no breezes breathe or wander. The grains rest exactly where they have settled, like tiny keepers of memory. Each one holds the faint imprint of meteor strikes, the long echo of the sun's radiation, and the delicate signs of everything that has ever brushed past them. Slowly, the pale light slips across these tiny guardians, illuminating their subtle patterns. In that stillness, one might imagine the distant echo of something alive, not in motion now, but perhaps once part of a far older story, one that drifts through the moon's hidden past like a gentle lullaby. Deep within the shadowed hollows, where sunlight only visits for brief timeless moments, the ancient rocks seem to hum with an almost imperceptible resonance. Even though there is no air to carry sound, the quiet story of the moon feels as if it vibrates through those stone ribs, weaving the faint possibility that something once moved, once breathed, or once clung to a distant, fragile hope. The glow rests tenderly on these surfaces, revealing nothing explicit, yet suggesting everything through silence. It is in this ambiguity that the mind wanders, imagining life that might have lingered, faded, or perhaps never completely slipped away. When explorers first gazed upward toward this pale companion of Earth, they dreamed of secrets locked within its frozen soil. As ages passed and technology advanced, the quiet curiosity deepened. Travelers imagined stirring footprints before humanity stepped there, or faint traces that might hint at forgotten microworlds tucked into cracks or shadows. Even now, when machines and memories circle the moon, there is something unmistakably gentle about its refusal to reveal everything. Its glow remains soft, almost reassuring, like a keeper of ancient stories that prefers slow telling, the kind that guides weary minds into effortless rest. The moon's surface, though harsh and unforgiving, holds a serenity that almost feels protective. The fine regolith blankets everything like an untouched snowfall that has existed for billions of years. Beneath it may rest remnants of cosmic dust, old molecules once warmed by ancient impacts, and perhaps the faint biological whispers delivered by asteroids wandering through the young solar system. All these possibilities lie softly under the pale glow, as if waiting for careful listeners to settle into stillness and let their imaginations flow slowly with the rhythm of the lunar night. If one could drift across this landscape, weightless and unhurried, the glow would feel like a soft invitation. Each crater would appear like a sleeping cradle, each ridge like a slow exhale of stone, each plain like an ancient page waiting to be read. The moon does not rush. Its story unfolds the way cold light spreads, delicately, patiently, in a way that eases the mind into calm curiosity. Even the thought of life lingering here, tiny, hidden, improbable, becomes part of the slow, soothing dream the moon naturally inspires. In the deeper craters, where sunlight rarely reaches, ice clings to grains of dust like fragile jewels. These icy particles have survived ages of silence, untouched by warmth or storms. Some imagine that within these frozen pockets, once upon a time, certain molecules might have met others, forming gentle patterns that hinted at the simplest beginnings of life. Whether these hints were fleeting or enduring remains a quiet question, one that the moon keeps tucked beneath its glow as though afraid to disturb the soft rhythm of stellar slumber. Far beneath the surface, ancient tunnels carved by volcanic breath stretch through darkness. These caverns, undisturbed for billions of years, cradle temperatures gentler than the surface extremes. Some dreamers imagine that if life had ever clung to the moon, perhaps it withdrew into these protected hollows as the surface grew colder and harsher. Whether real or imagined, these thoughts drift like slow-moving clouds through the mind, bringing a sense of curiosity wrapped in tranquility, like pondering forgotten chambers in a silent cathedral. As the earthlight reflects across the lunar plains, a soft blue tint covers the gray dust, painting the moon with hues that feel almost earthly. This gentle reflection connects the two worlds like a delicate thread. It whispers of old interactions between planets, of ancient exchanges of rock and dust during violent impacts. Some scientists have wondered if those exchanges once carried the faint touch of microbes between worlds. Though unproven, the idea lingers like a feather floating in the mind, lightly brushing against possibilities that do not disturb the stillness of thought. Even today, as spacecraft land, observe, and depart, the moon retains its undisturbed essence. The machines leave marks, but the silence remains unbroken. The pale glow continues to bathe the surface in its slow rhythm, restoring the feeling of timeless peace. And within that peace, questions rise like soft vapor. If life ever touched this place, even briefly, would the moon remember? Would the stones, cooled by eons, still hold its faintest signature? These questions do not demand answers. They simply lull the imagination into long, soothing contemplation. The moon's ancient lava plains stretch outward like dark, serene lakes frozen in time. Their smooth surfaces contrast against jagged highlands that look like folded blankets of stone. This landscape feels as though it has been tucked in by the universe itself, gently setting the moon into a restful posture. To imagine life, tiny, delicate, temporary, nestled somewhere within this vastness adds a hint of warmth to the otherwise cold terrain, like a soft ember hidden beneath empty ash. Between the rocks and the fine dust, the vacuum of space presses in quietly. Yet this emptiness feels more like a blanket than a void. It wraps around the moon, preserving every mark, every molecule, every ancient whisper. In this preserved stillness, the idea of dormant life, waiting or forgotten, becomes a gentle companion to the pale glow, not in a frightening way but in a calming, reflective manner. The mind wanders alongside the possibility without ever feeling lost. The moon's slow rotation brings long nights that stretch nearly 2 weeks, allowing darkness to settle like a deep breath held gently for far too long. Then the sunlight returns, spreading across the plains like a warm exhale. This rhythm, simple and predictable, would have shaped any fragile form that once clung to existence here. The thought brings a quiet comfort, as though understanding the moon's rhythm helps us align with its soft, steady pulse, easing our thoughts into deeper calm. Meteor impacts punctuate the moon's history, carving basins that reveal layers untouched since the solar system's youth. Within these layers, tiny minerals hold secrets about ancient environments. Some propose that certain conditions might have once offered brief shelters of warmth, just enough for chemical dances to occur, tiny sparks that echo the early steps of life. Whether those sparks ever brightened into something more is unknown, but imagining them feels like listening to a bedtime story whispered by the cosmos. As the pale glow moves across the ridges, shadows stretch long and tender, as though the moon is carefully cradling them. The shadows soften the harsh terrain, creating gentle contrasts that soothe rather than startle. In these contrasts, one might imagine the faint movement of something small, something that once drifted between light and shade. The moon invites such thoughts, not to disturb the mind but to relax it, letting wonder settle lightly, like lunar dust. The quiet suggests that if life ever existed here, it adapted to silence, cold, and stillness, conditions that now define the moon entirely. This makes the idea feel even softer, almost ethereal. It is less a question of biology and more a drifting thought amid the tranquil scenery. The moon becomes a storyteller, using light and shadow instead of words, guiding the listener into deep rest through slow, lingering possibilities. During moments of total stillness, even imagination seems to slow, falling into the same unhurried rhythm as the glow. Thoughts of ancient molecules drifting through volcanic vents or icy crevices merge with the soothing landscape. The moon, in its serenity, becomes a vast cradle for gentle speculation. It does not push the mind toward answers. It simply lets the questions float peacefully, like tiny lanterns along a quiet river. The earth in the distance adds comfort to this scene. Its blue glow rests upon the moon like a protective gaze, reminding the silent world that it is never truly alone. Some believe early Earth may have shared more than light, perhaps fragments of organic material traveled between the worlds long ago. If so, the moon might hold echoes of those exchanges, preserved in its eternal stillness. And though unconfirmed, the thought drifts softly, easing the mind into deeper calm. Beneath the surface dust, ancient glass beads created by fire and impact hide microscopic secrets. Some contain traces of water locked within them for billions of years. This water, though scarce, hints at environments where warmth might have briefly pooled. It suggests so gently that the thought barely stirs that the moon's past may not have been entirely barren. Yet the suggestion does not disturb, it soothes, offering a slow unfolding of possibilities like petals opening in slow motion. In the quiet hollows of the moon's south pole, the shadowed craters hold ice untouched since the solar system's earliest days. These frozen pockets might hold the softest clues, perhaps tiny chemical memories drifting in the ice. Whether they speak of life or merely mimic it does not matter in the moment. The gentle uncertainty wraps itself around the mind like a blanket, inviting rest rather than urgency. The pale glow, spreading across the landscape once more, feels like the moon's slow whisper telling us that mysteries need not be solved to be soothing. The possibility that life never fully left, or perhaps never fully arrived, lingers without tension. It becomes part of the moon's lullaby, a soft melody drifting across an ancient, silent world. Beneath the stillness, the story flows gently, guiding every listener toward a deeper, quieter breath, and inviting them to drift into the calm that the moon has kept for billions of dreaming years. Under the soothing hush of deep lunar stillness, the moon's face stretches outward like an ancient parchment, weathered by time yet carrying every memory with quiet dignity. Its gray surface, mottled with soft shadows and gentle rises, feels like the expression of a neighbor long overlooked, one that has watched Earth's oceans shift, continents drift, and species rise and vanish. This face, carved by cosmic winds and the silent touch of countless impacts, holds the patience of a world that has never tried to speak loudly, choosing instead to let its presence whisper in slow, calming waves through the void. Across this silent surface, immense basins lie like sleeping features, broad cheeks shaped by early catastrophes, and ridges like faint lines from millennia of stillness. Though lifeless in appearance, these scars have stories embedded in every softened edge. They tell of ages when meteors rained down like celestial storms, when molten seas glowed beneath a young sky. Now, in the pale glow, those ancient seas appear as dark plains, smooth and quiet. And as the eye drifts across them, it feels as if the moon's old face is gently leaning in, ready to share secrets from epochs when the solar system was still learning how to breathe. The highlands rise like solemn shoulders, carrying the weight of billions of years with a grace that does not demand attention. Their jagged peaks, worn yet proud, reflect the faintest light in fragile hues. These regions are among the moon's oldest, portions of its face that have hardly changed since the earliest collisions that shaped it. As one imagines drifting across these ridges, a deep sense of antiquity settles in, a sense that this neighbor has existed through storms we can't even fathom, surviving them with soft endurance. The stillness here feels like a lullaby that has been playing since the beginning. Craters, from tiny dimples to vast circular plains, dot the landscape like memories pressed into skin. Each one records an instant of cosmic history, a moment when something from the larger universe brushed the moon and left its mark. Instead of erasing these marks, the moon has held them close, storing each as a gentle reminder of the worlds and materials that have touched it. And because there is no wind to smooth them away, no rain to heal the scars, the memories linger in perfect calmness. The moon seems to embrace them, turning even violent history into a quiet record of resilience. On nights when Earthlight gently bathes the far side of the moon, the features soften into tranquil silhouettes. This distant hemisphere, unseen by human eyes for most of history, carries a face even more ancient and untouched. Its craters are deeper, its plains fewer, its silence somehow even heavier. Looking upon this side feels like witnessing the private face of a neighbor who reveals their quietest thoughts only in rare moments of trust. There is an intimacy in its loneliness, a soothing depth that makes the mind drift slowly, as though wrapped in the oldest silence imaginable. Somewhere between its highlands and plains, the moon's line of horizon curves like a restful sigh. Against the blackness of space, this curve seems almost alive with softness, leading the imagination to picture how many times this neighbor has watched Earth's dawns, Earth's storms, Earth's living breath. The moon's face has reflected the blue world for eons, observing gently without ever reaching out. In that long companionship, one senses a quiet bond, one rooted not in words or warmth, but in the simple, enduring presence of two worlds circling in peaceful rhythm. The Mare regions, those dark volcanic plains, appear like calm pools frozen in time. Though they were once hot and glowing, now they lie flat and undisturbed, mirroring the deep tranquility the moon projects. Sometimes the faint patterns of old lava flows can still be traced, winding in slow curves that soothe the mind. These ancient flows are like the moon's soft fingerprints, unique lines that reveal a distant past when it still pulsed with internal heat. Now cooled and quiet, they contribute to the gentle expression the moon wears, one shaped by both fire and silence. Along the rims of craters, the shadows stretch far and soft, forming arcs of darkness that cradle the bright edges. These shadows move slowly as the sun creeps across the sky, taking nearly a month to complete one full sweep. This slow dance of light and shade gives the moon's face a rhythm so tranquil that imagining it brings a sense of deep rest. The shadows do not rush or flicker. They drift with the patience of a world that has no storms to push them, no air to twist them. They offer a lullaby made of contrast and calmness. In the polar regions, where the sun skims the horizon like a tired lantern, the moon's face takes on an ethereal glow. Long shadows cut across the ground, forming delicate fingers of darkness. In some craters, sunlight has not touched the floor for billions of years, leaving pockets of eternal night. These zones hold some of the purest silence in the solar system, and imagining them feels like peering into the deepest thoughts of an old companion. Nothing stirs there, not dust, not light, not heat, only the patient stillness of time. The ancient wrinkles etched across the moon's surface, known as rills, appear like soft lines formed by gentle expressions. These long, winding formations trace paths where lava once flowed or crust once collapsed. Though shaped by geological activity long gone, they carry an elegance, as though the moon once smiled or winced, leaving faint traces behind. These features add depth to its face, showing that even a silent world once moved and changed, and now rests in a final state of unhurried peace. Small boulders cast long, delicate shadows in the low-angle sunlight, their tiny outlines stretching across the ground like sleeping guardians. These scattered stones may have been torn from crater walls or tossed across the plains by ancient impacts. Now they sit quietly, never shifting, never weathering away. Their stillness mirrors the moon itself, unchanged, undisturbed, and deeply restful. Observing them is like noticing the details on a wise face, subtle, enduring, and rich with unspoken stories. Dust layers, incredibly fine and soft, coat everything like a gentle blanket. This powdery regolith has been ground down by billions of years of tiny impacts, each one adding to the moon's quiet features. The dust catches light in a subtle way, making the surface shimmer faintly under the soft glow. Thinking about these particles, how each one holds the memory of countless micromoments, creates a sense of calm continuity, as though the moon's very skin is made of time itself, resting peacefully under the endless night. Some places on the moon hold clusters of overlapping craters, forming ripples of circles that look like the impressions of celestial raindrops. Each layer of impacts adds to the moon's aged appearance, giving it a texture that feels like folded pages of history. These ripples are delicate reminders of the constant interactions the moon has had with the universe around it. And yet, despite the violence that created them, they now appear serene, softened by ages of sunlight and silence. The ridges that arc across the Maria lie like the faint outlines of ancient muscles long relaxed. They rise gently above the plains, offering just enough variation to create soothing patterns across the terrain. These features suggest that the moon once stretched and shifted slightly, adapting to its cooling interior. Now they remain frozen in mid-gesture, forming the subtle expressions of an ancient face settling into eternal rest. Far from human eyes for millennia, the moon's far side carries a quiet majesty. Its landscape is deeper, rougher, more cratered, as though this side has absorbed the universe's hardest moments. Yet even in its roughness, there is a profound calm. The pitted ground looks like the weathered surface of an old friend who has endured countless challenges yet remains gentle. Imagining standing there, surrounded by infinite silence, can lull the mind into a soft, contemplative drift. Bright ejecta rays radiate from younger craters, stretching outward like faint, delicate brushstrokes. These rays are lighter in color, painted across the darker plains in soft lines that fade with distance. They form patterns reminiscent of quiet ripples on still water, frozen in place for eternity. Their presence adds a touch of innocence to the moon's ancient face, like traces of a younger moment preserved in time. The moon's overall expression, if one can imagine such a thing, comes from the interplay of light, shadow, shape, and stillness. This expression has watched Earth since before life flourished in its oceans. It saw the first forests grow, the first creatures walk, and eventually the first humans look up in curiosity. And through all this, the moon's face remained unchanged, calm and faithful. Thinking about this eternal presence brings a soothing sense of constancy, as though the universe itself is offering reassurance. Even now, when astronauts and machines leave their traces, the moon absorbs them quietly, adding them to the layers of its long history. Footprints that would vanish instantly on Earth remain here without disturbance. Equipment left behind sits exactly as it was placed, becoming part of the moon's expressions. These human marks, tiny in comparison to its vast age, rest gently on its surface like new memories added to an old soul. The moon's ancient face also carries the faint possibility of life's fingerprints, not in the form of thriving ecosystems, but perhaps in chemical hints or fossil-like whispers frozen within rocks or ice. Whether these signs exist or not, the notion does not disrupt the moon's serenity. Instead, it blends seamlessly into its character, adding a tender dimension to its age-old presence. The idea of a forgotten neighbor that may once have known life, even briefly, softens the imagination and encourages it to drift gently. The stillness surrounding this old face extends far beyond its surface, merging with the deep black sea of space around it. This infinite quiet amplifies the moon's calmness, making its presence feel almost like a soft glow floating in a vast dream. In this boundless silence, the moon becomes not just a celestial body but a soothing presence, guiding the mind toward deeper rest, deeper ease, deeper breath. To imagine this ancient neighbor is to slow the pace of thought, letting the rhythm of its long existence replace the noise of the present. Its face, shaped by eons yet perfectly still, reminds us that even worlds touched by fire and collision can settle into peace. And so, as one contemplates the moon's ageless expression, its craters, its plains, its quiet poetry, sleep drifts closer, like a soft tide rising gently around the shores of the mind. And in the end, the moon remains suspended in its eternal role, a silent companion that has never asked to be understood, only to be seen. Its ancient face, glowing softly in the dark, offers comfort simply by existing. And as the listener sinks deeper into calm, the moon's presence becomes a soothing reminder that even the oldest, most forgotten neighbors carry a profound, peaceful beauty, one that lingers softly in the mind long after the eyes close. In the soft, unbroken quiet of the moon's ancient body, there lingers a faint suggestion, so subtle it feels more like a memory than a fact, that long before its surface froze into eternal stillness, the moon may have known moments of warmth, moments when water whispered briefly through its hidden places. These echoes are not loud or certain, they drift like pale reflections across the mind, touching the imagination the way a warm breeze brushes a sleeping field. In contemplating them, one feels the moon's distant history stirring gently beneath layers of cold dust. Scientists who study lunar samples have found minerals that hint at tiny droplets of water locked within their crystalline hearts. These droplets, though minuscule, suggest the moon's interior may once have held far more moisture than its barren appearance implies. The thought is calming, not because it foretells bustling life, but because it softens the moon's story, revealing a chapter where heat, water, and geological breath mingled in delicate harmony. Imagining these droplets forming, cooling, and resting for billions of years lets the mind drift into a slow, soothing contemplation. The volcanic plains, now frozen into quiet darkness, were once seas of molten rock glowing with intense heat. In those early ages, gases, including traces of water vapor, may have escaped from the molten interior, rising like fragile sails into the lunar sky. The atmosphere they created was thin, fleeting, and quickly lost to space, but the idea of it, an ephemeral blanket of warmth around the young moon, lingers like a gentle dream. This vision of a briefly breathing world paints the moon in softer colors, as though it once held a secret pulse beneath its rocky skin. Some theories propose that during the moon's fiery youth, pools of liquid water might have formed temporarily on its surface, fragile, short-lived, and tiny compared to Earth's oceans. These pools would have evaporated within hours under the unrelenting radiation of space. Yet even the possibility fills the moon's old craters with a new kind of hush, the hush of something once warm touching a world now locked in cold silence. Thinking of this transformation, the mind slips slowly into the rhythm of ancient shifts and cooling tides. If these warm episodes existed, they would have shaped the moon's interior, leaving faint traces in minerals cooled in ways that differ ever so slightly from those in a purely dry environment. Some lunar glass beads, even those blasted from deep below the surface, contain water molecules. These beads act like tiny time capsules, carrying echoes of places where heat and moisture briefly coexisted. To imagine these beads lying quietly beneath the pale glow is to imagine the moon whispering fragments of its forgotten warmth, letting them surface only in the stillness of deep study. Deep beneath the surface, volcanic tunnels, long since frozen, stretch through the crust like quiet veins. In their earliest days, these tunnels may have been warm refuges, shielded from the harsh vacuum outside. Water vapor, drifting through these spaces, might have condensed on cooler surfaces, forming transient films of moisture that glistened in the dim glow of molten flow. The idea is soothing, like walking through an ancient cavern where traces of past warmth cling to the stone walls, echoing through time. On the moon's far side, where endless highlands rise under the faint glow of scattered starlight, certain minerals found within impact basins carry chemical signatures of an environment shaped by heat and fleeting moisture. Though the world above remained desolate, these minerals preserve whispers of a time when internal processes were more vibrant. Their existence fills the far side with a sense of deep, ancient memory, one that drifts through the craters like a gentle hum, calming and unhurried. Asteroid and comet impacts during the moon's early days may have delivered water and organic molecules, sprinkling them across the landscape like celestial seeds. Though the surface lacked the atmosphere to protect them, some may have seeped downward, settling into cracks and fractures where warmth from the moon's interior once flowed. These seeds never grew into life as we know it, but their presence adds softness to the moon's past, a hint that it once received the raw ingredients of living chemistry, even if only briefly. In the permanently shadowed craters of the poles, ancient ice lies hidden like forgotten letters sealed by time. Though this ice likely arrived long after the moon cooled, mixed with it may be molecules older than Earth's first oceans. When scientists examine these molecules, they find echoes of environments where water once moved freely. These echoes do not claim that the moon was once a wet world. Instead, they evoke the gentlest image of moisture touching stone, a fleeting embrace preserved in perpetual night. Some lunar rocks contain hydrogen isotopes matching those found on Earth, leading to the peaceful thought that both worlds were once connected through shared materials. These isotopes suggest water deep within the moon's mantle, water that might have survived the violent formation of the moon itself. The idea creates a sense of ancient companionship, a quiet bond between Earth and its satellite, formed from the same cosmic mixture. Imagining these shared origins feels like listening to two old friends recalling memories too ancient for words. In the quiet moments of scientific contemplation, some researchers imagine a moon that briefly held a thin atmosphere, an atmosphere created by volcanic outgassing that included water vapor. This atmosphere would have been fragile and temporary, lasting only tens of millions of years, but in cosmic terms, even that is a meaningful breath. The notion that the moon once exhaled into space lends it a gentle, almost human quality, as though it once whispered softly before retreating back into silence. As the moon cooled, its magnetic field faded, allowing solar winds to strip away the last traces of its atmosphere. In this quiet stripping, the moon's fleeting warmth was carried into space, leaving behind the still and airless world we see today. But the remnants of that warmth, locked in rocks, preserved in minerals, frozen in ice, remain like forgotten echoes of a time when the moon's face was not yet fully hardened by time. These echoes create a sense of peaceful melancholy, like looking at an old photograph of someone who once smiled. Some impact craters reveal glassy materials that formed under intense heat that may have allowed water to bind with minerals before cooling. These glasses, shaped by fire, now lie in tranquil darkness, their surfaces unchanging. They hold within them the memory of a moment when heat met moisture, a moment that has not repeated in billions of years. Imagining those moments feels like sensing the warm breath of a long-extinct world brushing faintly against one's thoughts. Lunar basalts, born from ancient lava flows, contain oxygen isotopes that hint at interactions with water while molten. These interactions were subtle, but they leave a gentle footprint within the stone. When scientists examine these isotopes, they hear faint traces of a warmer, wetter interior, an interior that once moved with slow currents of molten rock, carrying whispers of moisture through its chambers. Thinking of these isotopes is like listening to the softest tone in a lullaby, almost imperceptible yet soothing. The moon's mantle, though solid today, once pulsed with the energy of a young celestial body. In those moments, water might have existed within its molten folds, participating in chemical dances that shaped the early crust. These dances ended long ago, replaced by stillness, but their echoes remain detectable, like faint footprints on a long-forgotten path. Contemplating these ancient processes encourages the mind to relax, to breathe more deeply, to let the vastness of time wash gently over it. In the deepest parts of the lunar soil, trapped gases sometimes hint at the presence of ancient, hydrogen-rich environments. These environments may have allowed brief reactions that resemble the early steps of chemical life, not full life, not complex, but tiny, fragile chemical stirrings. Whether these stirrings ever progressed is unknown, but imagining them brings a soft warmth to the moon's history, as though a tiny ember once glowed beneath its surface before cooling forever. During the moon's early evolution, tidal forces from Earth may have created internal friction that generated heat. This heat could have mobilized water within the mantle, pushing it toward the crust in gentle currents. These currents left behind subtle chemical signatures, delicate fingerprints from a time when the moon's interior was alive with motion. These fingerprints now lie still beneath the dust, but sensing their presence brings a sense of slow, ancient movement like the faint pulse of a sleeping giant. The moon's crust contains minerals that form only in the presence of water under specific conditions. These minerals are rare, subtle, and easy to overlook, but their existence is a reminder that water touched the moon in more ways than mere ice from comets. They represent the quiet interaction of heat, moisture, and rock, a triad that, in other worlds, has led to life. On the moon, these minerals remain as gentle remnants of what could have been, soothing in their quiet persistence. Scientists studying lunar samples often describe the moon's hydrated minerals as fossil signatures of earlier states. These signatures do not speak loudly. They murmur of fleeting times when conditions shifted, when environments changed, when warmth caressed stone. To imagine these fossil whispers is to imagine a world that once hid small surprises beneath its hard exterior. Their soft presence invites the mind to settle into deeper reflection, like listening to distant echoes in an ancient hall. Even in the moon's present dryness, the existence of these traces touches something tender in the human imagination. They suggest that the moon was not always the cold, barren neighbor we see today. It had chapters, brief, quiet, and subtle, when water and warmth held meaning. These chapters do not change the moon's nature, but they enrich its story, turning it into a lullaby composed of both fire and ice, both breath and silence. As one continues to contemplate these echoes, the moon becomes a world of contrast, a frozen surface above the faint memories of warmth, a silent sky above the traces of ancient vapor. This duality calms the wandering mind, offering a serene equilibrium. It reminds us that even the coldest bodies can hold remnants of warmth, and even the quietest worlds can whisper stories of long-vanished change. And so, in the moon's frozen face, there lingers the softest echo of a warmer, wetter past, a past that may never be fully understood, yet gently cradles the imagination. In these echoes, one senses the comfort of deep time, of change slowed to a near stop, of ancient worlds settling into peaceful sleep. And as these thoughts drift softly through the darkness, the listener sinks deeper into rest, carried by the moon's quiet memory of warmth long gone. In the gentle hush of an imagined lunar twilight, where the sun's rays skim the rugged edges of long-forgotten craters, a quieter story stirs beneath the dust, a story woven not from rocks or frozen shadows alone, but from the faint memory of gases that once moved softly across the moon's surface. These gases, thin and fleeting, belong to an era when the lunar crust still shivered with heat, when volcanic sighs escaped through fractures, and when the moon, though never Earth-like, breathed in its own delicate, mysterious rhythm. And as this chapter unfolds, we drift slowly through that ancient atmosphere, letting each fragment settle over us like cool night air. Back then, billions of years ago, the moon was not the silent sculpture we see today from our windows or telescopes. It was still cooling, still reshaping itself from the intense violence of its birth. Magma seas bubbled beneath hardening plains, and fissures in the crust acted as pathways through which gases rose and dispersed. These weren't winds like those we know, not breezes brushing across open fields, but rather thin curtains of vapor that shimmered briefly before dissolving into space. Still, those gases told a story, one of heat, movement, and change, one that hums softly through time like a distant lullaby for anyone willing to listen. Volcanic activity, subtle by Earth standards but powerful for the moon, released a mixture of compounds that formed a temporary, fragile atmosphere. This atmosphere, far too thin to be breathable or protective, danced lightly above the ground, a transient veil that could linger for perhaps millions of years before thinning into nothingness. Scientists believe that some of these gases included carbon monoxide, sulfur compounds, and even water vapor carried upward by heat from the molten interior. Every time the moon exhaled, it reshaped its surroundings in ways we are only beginning to understand. These gases would gather in basins, drifting downward toward lowlands like Mare Imbrium or Oceanus Procellarum, where they might remain trapped slightly longer than elsewhere. In these regions, the gases contributed to the delicate chemical signatures we detect today, subtle traces locked into rocks, glassy beads formed from volcanic fountains, and the wispy-thin coatings on ancient mineral grains. Even now, countless ages later, the evidence waits quietly beneath layers of dust, as though patiently holding a memory it knows someone will eventually uncover. Imagine standing on that young moon, if such a thing were possible, surrounded by towering domes of cooling lava. The ground would still radiate warmth beneath your feet, and delicate strands of vapor would escape from cracks nearby. They wouldn't swirl dramatically, nor sweep across the landscape with force, but they would drift, almost lazily. This slow movement would give the impression of a world breathing at its own pace, entirely unhurried, entirely unaware of the stillness it would one day embrace. As these gases rose and fell, they interacted with the minerals around them. Tiny droplets of molten rock were thrown upward by volcanic fountains, cooling rapidly and capturing the chemical fingerprints of the gases in their glossy forms. These microscopic spheres, some no thicker than a hair, still hold precious details about what was present in the lunar sky at that time. They are like tiny memory capsules, preserving the faint echo of an atmosphere the moon once had, fragile and ephemeral. The dance of these ancient gases also helped shape the temperature of the moon's surface. Though extremely thin, the atmosphere would have softened the extremes just slightly, making nights a little less frigid and days a little less scorching. Not enough to nurture life as we know it, but enough to paint the moon with a gentler thermal rhythm. This rhythm, subtle as it was, played a role in how minerals formed, how lava cooled, and how certain deposits accumulated in sheltered regions. Some theories even suggest that pockets of these gases could have interacted with solar particles, creating temporary regions where more complex chemical reactions might have taken place. Though the moon lacked the stability needed for life to thrive, these interactions still would have created a more dynamic surface chemistry than what exists today. This complexity remains etched in certain deposits, particularly those in volcanic plains where gas release was most active. The lunar maria, those dark, broad plains we see from Earth, were shaped partly by this quiet dance of gases. As volcanic eruptions filled enormous basins with molten rock, gases trapped beneath the surface were pushed outward and upward, changing the texture of the lava as it cooled. Smooth surfaces, rippled flows, and glass-rich regions all owe some of their characteristics to the presence of these ancient vapors. In a sense, the moon's landscapes are as much sculpted by invisible breath as by solid stone. Water vapor, though rare, played its own small role as well. When released from magma, it drifted into the cold vacuum, where much of it was lost instantly, but a fraction may have been trapped in shadows or frozen into grains before being buried. These faint traces of water hint at brief interactions that shaped the moon's chemical potential, even if only momentarily. Today, missions detect water molecules hopping from shadow to sunlight, echoing the same delicate movement from long ago. In some areas, the gases reacted with hot basalt surfaces, leaving behind residues of sulfur that created subtle color variations. These faint hues, almost invisible to the naked eye but clear to instruments, record the last sighs of volcanic venting. They paint the moon not as gray and lifeless, but as a world that once pulsed with internal heat and evolving chemistry, a world with a hidden vibrancy. The gases didn't last long in a cosmic sense. Without a magnetic field to protect it, and without the gravity needed to hold gas tightly, the moon gradually lost its atmospheric whispers to space. Solar winds stripped particles away, thermal energy pushed lighter molecules outward, and time did the rest. Within a few 100 million years, the atmosphere thinned dramatically, leaving the surface exposed to the full harshness of space. Yet some remnants persisted, hidden in tiny traps. Deep craters near the poles, cloaked in perpetual shadow, acted as cold storage vaults. Here, any water vapor that drifted over the surface might have frozen instantly and remained undisturbed for billions of years. These cold traps are some of the moon's most intriguing features, preserving a record of ancient gases that once drifted freely through lunar air. In addition to water, other volatile materials settled into these dark hollows: carbon-bearing compounds, sulfur traces, and even rare isotopes became sealed in darkness, waiting for the day when robotic explorers would descend and scoop them up for study. These preserved materials are windows into the moon's earlier breaths, each particle a tiny letter in a long-forgotten script. The lunar interior played a crucial role during this era. As the mantle cooled, pockets of gas accumulated beneath the crust, causing bubbles and pressure zones. When enough pressure built up, eruptions occurred, releasing both lava and gas. The timing of these events shaped not only the landscape but also the pattern of gas distribution. Even now, seismic studies hint at structures beneath the surface that once acted as conduits for these exhalations. Occasionally, a stronger eruption would create glowing fountains many kilometers high. These plumes spread gas over wider areas, contributing to a short-lived thickening of the lunar atmosphere. Though still extremely thin, these brief expansions added complexity to the moon's behavior. The fountains also produced shimmering curtains of molten droplets that cooled into the glass beads we now find in lunar soil samples returned by astronauts and landers. The residues left behind by these gases altered the composition of the regolith. Grains became coated with compounds that slightly changed their reflectivity. Over time, the constant micrometeorite impacts mixed these chemically altered grains with ordinary dust, creating layers that record the moon's volcanic epochs with quiet precision. Each layer holds a whisper of what once hovered above it. Even today, there are hints that the moon isn't entirely finished with its gaseous secrets. Transient lunar phenomena, brief glows or localized hazes reported for centuries, may be linked to tiny releases of gas still escaping from deep within. Though faint and infrequent, these events remind us that the moon's internal world, though largely dormant, has not gone completely silent. It continues to breathe in the smallest, most delicate ways. Radon and argon, noble gases released by radioactive decay, occasionally seep out and drift across the surface before escaping into space. Instruments placed by astronauts detected these gases, proving that the moon's interior still has slow chemical activity. They move softly, almost imperceptibly, like the last whispers of a story not yet fully concluded, a tale carried forward across millions of years. And oh, the dance continues, not lively, not booming, but quiet, fragile, and enduring. These ancient gases play a role in shaping the moon's modern mystery, leaving clues for us to find in dark craters, glassy beads, and flickers of trapped molecules. The story becomes not just one of geology, but of breath, rhythm, and lingering memory. Each discovery made by rovers and orbiters helps us trace these threads backward in time. They form a map of the moon's ancient atmosphere, revealing how gases moved, settled, and escaped. The more we learn, the more deeply we sense the moon's history not as static but as something that once lived in its own quiet way. As you drift through this tale, imagine the moon exhaling slowly, softly, like a sleeping giant long after its dreams have faded. Its breaths were faint, but they shaped everything: the plains, the deposits, the chemical traces we now chase. Even in stillness, the moon carries the echo of motion. And in that echo lies a reminder: even worlds that seem silent, barren, and frozen can hold stories of warmth, movement, and transformation. Stories whispered through gases that rose and vanished, yet left their signatures behind in delicate patterns only time can reveal. As this chapter settles, let the image of those ancient gases drifting over black basalt plains linger with you. Let it slow your thoughts, calm your breath, and guide you deeper into rest. The moon's quiet dance is gentle, timeless, and endlessly patient, like a soft tide of history moving under a pale glow, inviting you to drift along with it into peaceful silence. When the first earthly companions approached the moon, the lunar surface, silent for eons, felt the softest tremor of change. There were no winds to greet the visitors, no murmurs of atmosphere to carry sound, only the endless stillness of a world that had watched Earth from afar since its formation. As the spacecraft drifted closer, moving with a grace born from precision and hope, the moon remained calm, its ancient plains waiting with patient emptiness. And though the machines came not with life in their circuits, they carried Earth's curiosity, Earth's dreams, and Earth's longing to understand this neighboring sphere that had long shone upon human nights. Long before humans arrived in person, mechanical scouts orbited, photographed, and listened to the moon with unblinking loyalty. These companions, simple in design yet profound in purpose, became the first to break the moon's isolation. They slipped into orbit like silent birds circling a forgotten land, mapping its scars, its shadows, and its buried stories. Their cameras captured landscapes no living eye had seen, sweeping lava plains, deep craters filled with darkness, and mountains rising like frozen waves. With each image sent home, they strengthened the invisible bridge between the moon and its distant observers. The moon received these visitors without resistance, its surface unchanged by their watchful presence. But in a soft, symbolic way, their arrival rekindled the ancient connection forged billions of years ago when Earth and Moon were born from the same cosmic collision. The machines were emissaries of a world that once spun molten beside the moon, and now, after ages of cosmic drifting, Earth had reached back across the void with minds and metal. These quiet companions became the moon's first guests since the cooling of its seas, and though they could not speak, their presence told the moon that it had not been forgotten. As more orbiters arrived, they uncovered new details that deepened the mystery of the moon's past. They traced the outlines of ancient lava channels, discovered mineral signatures, and glimpsed the delicate dust that coated every surface like powdered memory. These machines did not disturb the scenery. They simply drifted, observed, and whispered their findings back to Earth. In their gentle passes, they honored the moon's solitude while bringing its secrets into the light. They were both explorers and storytellers, floating archivists cataloging the forgotten pages of lunar history. Eventually, landers made their descent, their engines pushing small clouds of dust upward in slow, graceful plumes. These plumes settled again almost immediately, as though the surface were eager to return to its eternal stillness. The landers touched down lightly, their metal feet pressing into soil that had lain undisturbed for billions of years. No creature had ever stood there, no stream had carved paths, no wind had brushed grains into dunes. Only the sun, meteoroids, and time had shaped the ground. Now, the landers' tiny footsteps became a new kind of imprint, one made not by nature, but by purpose. These landers, still and shining beneath the harsh sunlight, became part of the moon's landscape. They sat quietly in the void, their instruments reaching outward to sense temperature changes, measure soil properties, and listen for seismic whispers. They watched Earth rise and fall above the horizon, recording each moment with a patient steadiness. And though they lacked consciousness, they acted as silent ambassadors, representing the first physical touch between Earth and its companion since the early cataclysms that shaped both worlds. With the arrival of human missions, the moon felt something new, movement driven by life. The astronauts' steps were gentle but deliberate, pressing footprints into the powdery regolith that would remain unchanged for millennia. Their words could not travel far without air, but the vibrations of their presence, small, steady, and cautious, echoed faintly through the soil. In those moments, the moon witnessed beings who looked up at it for countless generations finally standing upon its face, breathing softly beneath their helmets, gazing at the landscape with a mix of awe and humility. Their tools, though simple, extended Earth's touch farther. They dug shallow trenches, lifted rocks, and placed instruments meant to listen to the moon's heartbeat. They measured tremors caused by meteor impacts, watched how dust behaved without air, and studied the heat rising from the ancient crust. Even these tiny interactions added new layers to the moon's story, layers made not by geological forces but by intention. The astronauts worked quietly, moving slowly in the reduced gravity, as though respecting the world that had welcomed them with silence. The scientific packages they left behind continued their work long after the astronauts departed. These instruments clicked, recorded, and transmitted data across the void, tirelessly tracking temperature shifts, moonquakes, and traces of escaping gases. For years, they kept watch like nocturnal guardians, standing under the pale glow of Earthlight. Their signals traveled homeward in soft pulses, carrying knowledge that deepened humanity's understanding of not just the moon, but of planetary evolution, of solar influence, and of the shared history between these two celestial companions. Later robotic missions returned with more advanced tools, able to detect faint chemical signatures, map surface minerals from orbit, and probe the hidden depths of polar craters. They discovered frozen water tucked away in places no sunlight had touched for billions of years. This discovery brought new excitement, for it hinted that the moon, though dry and harsh, still held elements that once drifted through its ancient atmosphere. These earthly companions, floating and landing with precision, continued the work of unraveling the moon's quiet mysteries. As technology advanced, new orbiters mapped the entire surface with astonishing detail. They traced soft gradients in soil composition, detected tiny variations in temperature, and even spotted disturbances caused by old spacecraft. The moon, with all its stillness, became a vibrant canvas of data. Each pixel, each measurement, each captured shadow revealed a new nuance in its story. Earth's machines had become extensions of human sight, enabling the world below to see its lunar neighbor more intimately than ever before. The moon accepted them all without objection. It had endured asteroid impacts, volcanic eruptions, and the slow freeze of time. The arrival of delicate machines did nothing to disturb its calm. Instead, their presence highlighted how deeply Earth sought to understand the world that had inspired myths, guided navigators, and shaped tides. The moon, once distant and unknowable, now felt closer, almost familiar, thanks to these mechanical travelers that bridged the gap. Even from afar, Earth observed its machines resting on the surface, their long shadows stretching across crater floors. These companions, though motionless, symbolized humanity's persistence, curiosity, and gentle ambition. They became part of the moon's identity, a reminder that even a silent world could be touched, explored, and honored with care. Their quiet waiting became a shared experience between two bodies linked by gravity and history. Future missions brought rovers capable of moving across the landscape with cautious, deliberate steps. They climbed crater rims, studied rocks, and peered into shadows. Their wheels left thin tracks that traced curious paths across the dust. These tracks, too, would remain untouched for millions of years, preserved as a record of exploration. The rovers, though driven by commands from afar, acted almost like wandering monks, exploring sacred ground with patience and reverence. Each rover carried instruments designed to study ancient minerals, the chemistry of soil, and the faint remains of volcanic gases. Their discoveries enriched humanity's understanding of how the moon evolved, how it cooled, and how its surface recorded memories of its past. These machines, small but resilient, became storytellers in their own right, uncovering chapters written in dust and stone long before any eye had witnessed them. The moon's silence amplified the importance of every signal sent home. A simple temperature reading became a message from a world with no air. A seismic tremor grew into a clue about internal layers still shifting slowly. A chemical signature revealed hints of processes frozen in time. Earth listened intently to these messages, interpreting them with care, building a more complete picture of the moon's life. Even now, as new missions prepare to return, the moon continues to host the artifacts of earlier visitors, silent reflectors that bounce laser beams back to Earth, landers resting like metal petals, rovers asleep beneath layers of dust. Each object is a fragment of Earth's story embedded within the moon's. Together, they create a mosaic of curiosity across the surface, a testament to the gentle persistence of exploration. In this quiet arrival of earthly companions, the moon has gained not noise, not disturbance, but presence, human presence, even in the form of machines. These visitors bring no harm, no disruption. but only questions, measurements, and admiration for the ancient world they study. And the moon, ever calm, offers its secrets slowly, as though whispering them into instruments that listen with unbroken patience. The relationship between Earth and Moon has always been one of gravitational embrace, but now it extends through knowledge. Earth reaches outward with technology, seeking understanding, while the Moon answers with data and silent acceptance. It's a slow, soothing exchange, one that unfolds gently across decades, mirroring the natural rhythm of celestial bodies moving through time. As the world continues to send new machines, the pattern repeats: gentle arrivals, quiet studies, and peaceful departures. This cycle becomes a soft heartbeat of exploration, steady and comforting, reminding humanity of the quiet wonders that surround it. The moon's surface, once untouched for eons, now hosts traces of its closest neighbor, not as scars, but as signs of curiosity and connection. Every earthly companion, whether a small orbiter or a towering lander, becomes part of the moon's ongoing story. Each contributes to the deepening bond between the two worlds. Each helps humanity drift deeper into understanding, and each stands in stillness beneath the glow of the sun and the reflection of Earthlight. And as this chapter settles, imagine those machines resting gently on the lunar plains, their shadows long and their metal cool beneath the cosmic night. Imagine them waiting, patient and silent, as though listening to the moon's slow, ancient breaths. Let that image guide your thoughts downward into softness, into quiet, into stillness, into peace. In the stillness of the moon's surface, beneath layers of dust laid down grain by grain through billions of silent years, there rests a kind of memory, one that behaves like seeds, though not the seeds of plants or forests or anything that blooms in warmth. These seeds are fragments of chemistry, pieces of energy, and whispers of processes that once pulsed faintly across the moon's crust. They lie preserved in the regolith, the powdery soil formed by constant impacts and cosmic weathering, frozen in time much like ancient thoughts caught in a moment of history that refuses to fade. Here, buried beneath quiet layers of gray, the moon holds echoes of processes that might have brushed against the edges of possibility. These frozen seeds are not alive, but they resemble the earliest steps toward complexity. They started when the moon was warmer, when volcanic exhalations filled fleeting pockets with molecules that reacted in gentle, subtle ways. Some of these molecules settled into the dust, becoming trapped as the temperature dropped and the atmosphere vanished. Instead of drifting away into space, they lodged into tiny crevices, clinging to mineral surfaces where they remained protected from sunlight and radiation. Over time, more layers buried them, sealing them in a kind of cosmic cold storage. The regolith itself is unlike Earth's soil. It has no organic matter, no moisture, no life to reshape it. Every grain is sharp, jagged, and ancient, created by micrometeorite impacts that shattered rocks into fine particles. These grains, though harsh and inhospitable, possess surfaces that can hold thin films of chemicals that once drifted through the moon's temporary volcanic atmosphere. These films acted as the first coating, a microscopic veil that captured molecules before they could evaporate or escape. As the moon cooled further, temperatures in the regolith dipped so low that certain molecules became locked in place. Even without an atmosphere to protect them, some compounds survived by hiding within the shadows of larger grains or binding tightly to crystalline structures. Over millions of years, the constant rain of cosmic particles altered some molecules slightly, but many retained recognizable shapes. Like dormant seeds buried beneath frost, they waited not for warmth, because warmth would only release them, but for discovery. Among these chemical fragments are traces of water, sulfur, carbon compounds, and other volatiles that once drifted upward from the moon's interior. Each of these represents a small chapter in the moon's earlier days, when heat still pulsed through its mantle and volcanic vents breathed out gas into the darkness. When volcanic fountains rained molten droplets across the plains, some landed hot enough to melt surface grains together, forming glass beads. These beads, in cooling, trapped molecules within their smooth interiors, preserving them with remarkable fidelity. Imagine a single glass bead, no larger than a grain of sand, sitting untouched for over 3 billion years. Inside it, a tiny bubble forms, a bubble containing the faintest mixture of gases released in a long-forgotten eruption. That bubble becomes a sealed time capsule, a frozen seed of ancient lunar activity. To scientists, these bubbles are keys that unlock stories about what the moon's internal chemistry once was, how hot the eruptions were, and what gases moved through cracks in the crust. Other seeds are found in the polar regions, where the cold is so deep that buried molecules can remain stable for eons. In these areas, the regolith acts like a trap, catching volatile molecules that drift slowly across the surface. When sunlight touches them, they hop. When darkness returns, they settle. This process repeats endlessly until a molecule eventually finds its way into a crater where sunlight never reaches. Once there, it freezes solid, preserved in a cold so intense that it is nearly absolute stillness. These frozen molecules are among the purest records of the moon's ancient breath. Some seeds are not chemical at all, but energetic. Cosmic rays, solar wind particles, and stray photons embed themselves into regolith grains, altering their structures and leaving behind traces of their journeys. These energetic signatures behave like inscriptions carved by invisible hands. They show when the sun was more active, when solar storms erupted, and even how the moon's orbit shifted subtly over time. Though not physical seeds, they are seeds of information embedded in dust that never forgets. Over billions of years, meteorites of all sizes have struck the moon, churning the regolith like a slow, grinding machine. This process mixed ancient layers with newer ones, blending seeds from different eras into a complex stratigraphy. Within a single handful of lunar soil, one might find molecules billions of years apart in age, each preserved in its own unique way. It is as if the moon gathered fragments of its entire past and folded them gently into one another, creating a soft, dusty archive beneath the surface. Some meteorites brought foreign seeds, tiny compounds formed elsewhere in the solar system or even beyond. These interstellar molecules arrived with little fanfare, landing in absolute stillness. They became part of the moon's library of chemical history, mixing with native gases and volcanic residues. Though small, they hint at the broader journeys matter takes across space, and how worlds share materials through impacts and cosmic drift. Even Earth itself has contributed seeds to the moon's soil. During ancient meteor impacts on Earth, fragments of the planet were launched into space, eventually landing on the moon's surface. Some of these fragments carried tiny traces of Earth's early oceans or atmosphere. Though heavily altered by time and radiation, they still whisper of a past when both Earth and Moon were young and exchanging materials more freely. These rare remnants represent a strange reversal, Earth leaving its own seeds on the Moon in a process nature orchestrated long before humans arrived. One of the most fascinating aspects of regolith seeds is how stable they remain. Without wind, water, or biological decay, the Moon preserves its history with extraordinary precision. On Earth, ancient chemical traces are erased by erosion, heat, life, and transformation. But on the Moon, time does not wash things away, it simply covers them gently with new layers. Each layer is a page in a book that has been accumulating since the Moon's birth. When astronauts collected samples during the Apollo missions, they unknowingly gathered these frozen seeds, tiny pieces of ancient chemistry that would later reveal details about the Moon's volcanic history, its interior temperature, and its atmosphere's composition. Back on Earth, scientists sliced open glass beads, heated grains to release trapped gases, and analyzed isotopes to trace their origins. From these small seeds, entire histories blossomed in laboratories, stories written not in ink but in gas trapped inside beads no larger than tears. Today, new missions aim to return to the Moon's polar regions, where some of the oldest and coldest seeds remain untouched. These missions hope to retrieve samples that have never experienced warmth, not even for a moment. Such samples may contain molecules older than Earth's earliest life, preserved in such pristine condition that they offer a rare glimpse into the chemistry of the early solar system. In these frozen seeds, scientists hope to find clues not just about the Moon, but about how planets form and how life begins. The Moon's surface also contains seeds of radioactivity, uranium, thorium, and potassium trapped in rocks. Over time, their decay produced heat and gases that once contributed to the Moon's volcanic activity. These radioactive seeds offer insight into the Moon's thermal evolution, revealing how the interior cooled, how long eruptions lasted, and why volcanic activity eventually ceased. By tracing the distribution of these radioactive grains, we can reconstruct the moon's fading internal heartbeat. Even the dust itself, electrostatically charged by sunlight and plasma, behaves like a seed in motion. At dawn and dusk, dust grains lift slightly above the surface, floating for seconds or minutes before settling again. This gentle, barely perceptible movement redistributes seeds across the surface, spreading molecules, energetic particles, and mineral fragments into new arrangements. Though tiny and slow, this motion shapes the texture of the regolith, giving it layers of subtle complexity. Some theories suggest that the moon's frozen seeds may have interacted slightly with solar particles, creating faint, transient chemical reactions. These reactions are not signs of life, but signs of chemical curiosity, processes hinting at how simple molecules behave in extreme environments. Though tiny and fleeting, they add another thread to the moon's quiet tapestry of change. The seeds, frozen in dust, create a bridge between the moon's violent beginnings and its peaceful present. They represent the remains of volcanic breaths, cosmic visitors, solar whispers, and even fragments of Earth itself. Each seed is a small relic of a moment, a reaction, or an event long past, preserved so perfectly that it feels as though time itself softened around it. And now, as new explorers prepare to return, they aim to uncover these seeds with care, knowing they hold answers that have waited patiently beneath silent regolith. The moon will not resist. It will simply reveal its secrets softly, one grain at a time, as though exhaling stories it has held onto since the dawn of its existence. As you drift deeper into this quiet chapter, imagine those seeds resting peacefully under layers of dust, untouched, unmoved, preserved through the slow passage of cosmic nights. Picture them lying in stillness so complete that even time moves gently around them. Allow the image to settle in your thoughts, easing your breath, guiding you into a calm as soft as lunar dust. When the moon settled into its long, quiet orbit beside Earth, it believed that its isolation would remain absolute. With no atmosphere to cushion its surface, no oceans to stir its dust, and no life to reshape its stones, the moon expected only silence and slow decay. Yet the universe is never completely still. From beyond the solar horizon, streams of particles flowed through space, cosmic winds made not of breeze or warmth but of charged fragments racing faster than sound could ever travel. These winds, faint yet persistent, brushed the moon's surface for billions of years, leaving behind more than light, more than energy. They delivered whispers of chemistry and history carried across unimaginable distances. The moon, lacking a magnetic shield, stood exposed beneath these particles. Every grain of regolith became a witness to their arrival. When cosmic rays struck, they burrowed into stone, leaving trails of altered atoms in their wake. Some particles broke apart molecules embedded in the dust, rearranging them into new forms. Others introduced tiny fragments of matter from faraway stars, embedding themselves like seeds of distant worlds. Though each particle was small, the collective influence of billions over billions of years became a quiet chorus shaping the moon from the outside in. Solar wind, faster and more frequent than cosmic rays, brushed the moon constantly. These particles carried hydrogen, helium, and other elements born in the sun's raging fusion core. When they collided with the moon's surface, they implanted themselves into the uppermost layer of dust. Over time, hydrogen atoms gathered in mineral grains, bonding weakly with oxygen locked inside the rocks. These tiny unions created faint traces of water molecules so few and fragile that they vanished under sunlight. Yet in darkness and cold, they sometimes survived long enough to drift across the terrain. As these solar-borne particles hopped from grain to grain, they moved like invisible fireflies, driven only by temperature changes. When sunlight warmed one region, the particles lifted and drifted toward colder areas. This delicate movement shaped patterns of hydration across the lunar soil, leaving behind chemical fingerprints that reveal how temperature cycles sculpted the moon's surface. Though the moon remains barren, these processes hint at a kind of quiet chemical dance powered entirely by sunlight and vacuum. Cosmic winds also delivered elements older than the solar system itself, remnants of exploded stars, broken fragments of ancient galaxies, and particles forged in places no human mind has fully imagined. These particles, traveling near the speed of light, struck the moon with incredible force. But instead of damaging it beyond recognition, they altered its chemistry in subtle ways. Some particles embedded themselves into rocks, becoming eternal guests. Others triggered reactions that reshaped the atomic structure of minerals. Each particle became a tiny note in the moon's long, silent story. One of the most fascinating consequences of cosmic winds is the formation of helium-3, a rare isotope created when solar wind particles implant themselves into the regolith. Over time, these particles accumulated, offering scientists a glimpse into the sun's ancient rhythms. The moon became a natural archive of solar activity, recording fluctuations in solar output like tree rings store memories of seasonal changes. And because these particles were never erased by wind or water, their record remains pristine. High-energy cosmic rays did more than alter atoms. They created structural defects within crystals buried deep in the regolith. These defects behave like tiny scars, marking each particle's violent passage. By studying these scars, scientists can determine how long a grain has been exposed to space, revealing the slow geological turnover of lunar soil. Each layer of dust tells a story of impacts, radiation, and chemical evolution, all influenced by winds that carry more history than light alone. These cosmic winds also influence the color of the moon's surface. Over time, interactions between solar particles and iron-bearing minerals created microscopic beads of metallic iron. These darkened the regolith, a process known as space weathering. As a result, old surfaces on the moon appear darker and redder than fresh impact sites. This phenomenon allows scientists to determine the relative age of features across the moon's landscape, simply by observing their shades. It is as if the winds painted the moon slowly, grain by grain, marking the passing of cosmic time. Though the moon has no magnetic field, it possesses tiny localized magnetic anomalies, areas where the crust retains traces of ancient magnetism. These pockets interact with solar wind particles, creating miniature magnetic shields. Within these regions, particles struggle to penetrate the surface, leading to lighter-colored swirls known as lunar swirls. They look like delicate brushstrokes painted across the ground, formed not by water or erosion but by invisible winds shaped by ancient magnetism. The moon's polar regions became special gathering places for particles drifting across the surface. As cold traps, they capture molecules that hop from warmer areas. Over billions of years, solar wind hydrogen combined with oxygen in rocks, eventually migrating toward these frigid craters. There, the molecules froze and remained untouched. These deposits represent a long, gentle journey driven by the soft push of solar radiation and cosmic winds, forming reservoirs that hold secrets about the moon's chemical evolution. Cosmic winds also subtly modified minerals deeper below the surface. Some particles triggered the formation of exotic isotopes in rocks buried beneath centimeters of dust. These isotopes reveal how long the rocks have remained undisturbed, allowing scientists to reconstruct events such as meteor impacts, volcanic eruptions, and surface turnover. Each isotope acts like a timestamp written by cosmic particles that have traveled across galaxies. As the solar system drifted through different regions of the galaxy, the intensity and composition of cosmic winds changed. Quiet periods alternated with storms of high-energy particles. All of these fluctuations left traces on the moon's surface, turning it into a quiet witness not just of its own history but of the galaxy's broader cycles. The moon holds memories of times when the sun passed through dense interstellar clouds, regions of intense radiation, and periods of calm cosmic drift. Though the moon lacks weather, cosmic winds behave like a strange, invisible climate. They erode surfaces, implant chemicals, create isotopes, and shape the regolith. Without these winds, the moon's surface would look very different, brighter, less chemically diverse, and lacking many of the subtle features that intrigue scientists today. The winds, though harsh, brought complexity to an otherwise simple world. Some particles, enriched with heavy elements, carry the history of stars that lived and died long before the solar system formed. When they struck the moon, they embedded small fragments of stellar memory into the dust. These fragments remain identifiable even after billions of years. They act like tiny messengers, each one saying, "I was born in the explosion of a sun you never saw." The moon collects them without transforming them, preserving them in their original cosmic forms. The lunar regolith, enriched by these particles, became more reactive over time. Although no biological processes ever took place there, the minerals transformed slowly as radiation and particles rearranged their internal structures. These transformations resulted in new mineral phases observable only on airless bodies. They are the Moon's unique minerals, shaped by cosmic winds rather than Earth's atmospheric processes. Scientists studying lunar soils in laboratories discovered that many grains contain layers, outer coatings formed by the constant bombardment of solar particles. These rims hold hydrogen, helium, neon, and other elements implanted over billions of years. Each rim is like a thin timeline, with older layers deeper inside and younger layers near the surface. It is a stratigraphy made not by sediments but by windless winds. During intense solar storms, the Moon received bursts of particles far stronger than usual. These storms altered the chemistry of exposed grains and occasionally penetrated deeper layers. By studying isotopes affected by these storms, scientists learned about the Sun's ancient activity levels, far beyond what Earth's atmosphere allows us to see. The Moon became a second observatory, one that quietly recorded solar outbursts through scars in its dust. Even the faintest particles contributed to evolution of the Moon's surface. Over millions of years, hydrogen implanted by solar winds helped shape the distribution of hydroxyl molecules. These molecules, though fragile, represent a process that transforms barren minerals into chemically active surfaces. In this way, the cosmic winds pushed the Moon just slightly toward complexity, not toward life, but toward a richer chemical diversity. As future missions prepare to analyze lunar soils more deeply, they hope to reconstruct how cosmic winds changed over time. By comparing samples from different regions, scientists can uncover which parts of the Moon were most exposed and which were protected by magnetic anomalies. These studies may reveal how the solar system's movement through the galaxy altered the intensity of cosmic particles. The Moon's quiet acceptance of cosmic winds shows how even a world without life can evolve in subtle ways. The wind shaped its surface, colored its plains, altered its minerals, and enriched its soils with particles from distant stars. They show that isolation does not mean stagnation. Even the most silent worlds
hear whispers from the universe. In the end, the cosmic winds brought more than light, they brought stories. Stories of the sun's past, of stars that died long ago, of cosmic storms and gentle drifts, of hydrogen atoms searching for rest in the cold dust. And though the Moon never breathed or grew, it collected these stories with patience, letting them settle quietly into its regolith. As you let these images drift across your thoughts, imagine cosmic particles gliding softly toward the Moon, settling into dust as lightly as snow on a quiet winter night. Imagine them freezing there, untouched, preserved, waiting through eons. Let the slow, cosmic stillness guide your breathing into softer rhythms, drawing you gently toward rest, as peaceful as the lunar surface beneath the endless sky. The story of the Moon's ancient whispers grows softer as we drift toward the strange glitter hidden beneath its dust, tiny spheres of glass, scattered like forgotten pearls across a desert that has never known rain. These beads, though silent and still, carry the weight of memories older than any human dreaming. They were born not from gentle processes, but from the sudden kiss of cosmic fire, meteor impacts so fierce they melted lunar soil and sent droplets flying through cold vacuum, freezing into perfect spheres before falling back like frozen tears. And as we settle our thoughts into this quiet landscape, the presence of these beads feels like the Moon's attempt to leave behind small clues, tiny lanterns sparkling faintly in a world without wind. Each bead lies where it fell, untouched for millions or even billions of years, resting in the same slow pose in which it first cooled. Their surfaces, though hardened glass, hold subtle textures carved by the vacuum and sunlight, the kind of details that reveal how slowly time passes on the Moon, how gently its environment shapes what falls upon it. And as you lean in, imagining yourself brushing dust aside with slow, dream-heavy fingers, you might sense the delicate imprint of cosmic history preserved inside each sphere. They are tiny, but their story expands outward like soft ripples across a lake of starlight. Scientists once considered them merely geological afterthoughts, impact debris with no secrets to tell. But with patient listening, we discovered they are reservoirs, capable of locking away gases that brushed against them in the moment they formed. Each bead is a bottle, sealed by heat and frozen by vacuum, storing samples of what the Moon's environment once offered. And in their hollow spaces or microscopic traps, we find whispers of hydrogen, traces of water molecules, and signatures of solar wind, faint, but undeniable clues that water may be produced, stored, and preserved across the moon in ways we never expected. Inside these tiny globes, far smaller than pearls, the story of lunar hydration unfolds in a slow unfurling of understanding. Scientists, carefully cracking them open or heating them to release the trapped molecules, found that each bead holds a droplet of lunar moisture, so little individually, but unimaginably vast when multiplied across the endless lunar surface. You can imagine it, trillions of beads, each carrying the ghost of a water molecule, a cold archive of interactions between moon and Sunday. The beads, once thought barren, now glow with the subtle promise that life's materials may linger longer than we ever guessed. Picture them forming during impact events, molten droplets hurled into the sky as plumes of vaporized regolith stretch upward like silent fountains. These droplets spin through vacuum, surface tension smoothing them into spheres as they cool. Then they fall back, sometimes bouncing lightly upon the powder before settling into stillness. Inside each bead, the hot interior cools around any gas present in the moment of formation, sealing it as perfectly as amber trapping ancient insects. And there they wait, millions of years passing while the pressureless sky leaves them untouched. What makes these beads so mesmerizing is not just their beauty or fragility, but the paradox they represent. The moon, a world long dismissed as dry and dead, may hold water created and preserved in ways we never expected. The solar wind, streams of charged particles flowing endlessly from the sun, strikes the lunar surface with quiet persistence. Hydrogen seeps into minerals, bonds with oxygen in the rocks, and forms water molecules that migrate into these glassy hollows. And once trapped, they remain, preserved in perfect stillness as though held in gentle lunar palms. The beads also serve as a type of time capsule, offering clues not only about water but about the solar wind's behavior across nearly the entire history of the moon. Their chemistry records the variations in solar activity, like a diary written in atomic script. As researchers study beads from different ages, some born billions of years apart, they read changes in solar intensity, shifts in the cosmic environment, and subtle variations in lunar surface conditions. Each bead is a chapter, tiny but essential, in understanding how space weather shapes the surfaces of airless worlds. Imagine walking slowly across the quiet lunar regolith, your boots sinking silently into grey powder as your lantern casts a soft glow over the ground. Beneath your steps, countless beads glimmer faintly, invisible until the light touches them just right. They are scattered like a secret treasure, not arranged by any hand, yet collectively telling a story that feels deliberate. In their presence, even the vast emptiness of the moon seems briefly intimate, as though holding onto memories no world should be able to keep without atmosphere or warmth. Some of these glass beads formed far deeper underground, inside ancient volcanic eruptions that once painted the moon's surface with fountains of basaltic fire. Those beads, lifted by volcanic plumes billions of years ago, contain not solar wind but native lunar water from the moon's interior, water that suggests the lunar mantle held far more moisture than anyone expected. These deeper beads whisper of a time when the moon was young and alive with molten seas of magma, when its interior still pulsed with heat and movement. Their existence changed how we understand the moon's birth and cooling. The volcanic beads tell a story of delivery and preservation, molten droplets rising through volcanic vents during explosive eruptions, carried high into the vacuum before cooling and falling back. Inside them, scientists found water concentrations hidden in their glassy matrices, preserved so well they serve as windows into the moon's interior chemistry. This discovery hinted that Earth and Moon may share more in their early histories than once thought, with water potentially inherited from the same primordial materials that formed both worlds. But the impact-formed beads are different, more numerous, more widespread, and more influenced by solar wind than ancient volcanic processes.
Their ability to store water suggests a dynamic exchange between moon and sun, one that continues even now. As the solar wind flows, hydrogen trickles into minerals within regolith grains, forming new water molecules that subsequently migrate into beads. And each time a new impact creates fresh beads, it refreshes the moon's ability to hide away these tiny droplets of moisture for unimaginable spans of time. This idea that water moves across the lunar surface through microscopic journeys, driven by the sun's breath, gives the moon a quiet dynamism. It is not alive, but it is not perfectly still. Processes happen in slow, whisper-soft cycles, hydrogen arriving, water forming, molecules hopping from grain to grain under subtle thermal shifts, and eventually settling into glass beads that cradle them like delicate eggs. You can imagine each molecule drifting alone across cold dust, drawn by temperature gradients too gentle to feel, until it finds safety in a glass sphere. And when researchers heat these beads in labs back on Earth, watching the trapped molecules escape, they are momentarily witnessing a reversal of billions of years of stillness. It is almost like hearing a whisper released from its sealed chamber. This moment, though purely analytical, feels strangely poetic. Scientists freeing ancient water from ancient glass, allowing something trapped since before humanity existed to finally breathe again. That is the quiet magic of these beads, their ability to connect us to epochs so distant we can only drift toward them in dreams. As we look forward to future lunar bases, these tiny glass spheres become more than scientific treasures, they become potential resources. The water they store, multiplied across the surface, could one day be harvested, providing astronauts with hydration, oxygen, and even fuel. The idea that millions of years of solar-wind interactions could supply tomorrow's explorers feels almost like the moon preparing itself for our return, laying aside small gifts in glass cases for when we are ready to retrieve them. Yet even as we imagine their future uses, it is important to remember their ancient purpose. The beads themselves do not try to serve, they simply persist, holding whatever they captured in the moment of their creation. Their value comes not from intention, but from endurance. This makes them symbols of the moon itself, silent, unchanging on the surface, yet full of hidden stories locked within. They are reminders of how much meaning can reside in the smallest things, especially in worlds where time moves slowly and each preserved detail becomes precious. The way these beads interact with sunlight is also a quiet wonder. Though their transparency is subtle and often clouded by embedded minerals, their rounded shapes scatter light in gentle halos, giving them a faint shimmer against the otherwise matte lunar dust. This shimmer is not bright enough to be seen from afar, but up close, under the right angle, it looks like starlight trapped in tiny spheres. This fragile beauty contrasts sharply with the violence of their birth, reminding us that even catastrophic events can leave behind delicate artifacts. Over billions of years, micrometeorite impacts continually churn the lunar soil, burying some beads deeper while lifting others closer to the surface. Each time this slow, random mixing happens, the beads experience new conditions, new temperatures, new exposure levels, new opportunities to trap or release gases. Their chemistry changes so slowly that each sphere becomes a layered record, storing traces of every environment it has survived. It is as though they carry multiple lifetimes, each etched into microscopic walls. When astronauts first brought these beads back during the Apollo missions, no one expected the revelations they would later provide. The beads were collected simply as part of the lunar soil, packed away with little fanfare. Only decades later, with improved analytical tools and new scientific questions, did their hidden value emerge. This delayed recognition adds to their quiet mystique. They waited patiently through the years, offering secrets only when humanity became curious enough and capable enough to hear them. Some beads contain tiny bubbles, microscopic voids left behind during their rapid cooling. Inside these bubbles, gases trapped during their formation remain perfectly preserved. Scientists analyzing them can determine the composition of ancient lunar atmospheres, tenuous, short-lived exospheres created during impact events. These momentary atmospheres would have been gone within hours or days, yet their memory survives in beads no larger than grains of sand. It feels like finding the preserved breath of a world that never truly breathed. The beads also help explain how water moves across the moon's surface in ways once considered impossible. Molecules trapped within them could later be released by micrometeorite strikes or intense sunlight, contributing to the moon's extremely thin, transient exosphere. From there, some molecules travel to permanently shadowed regions, craters that never see sunlight, where they freeze into ice. Thus, the beads are part of a strange lunar water cycle, ancient and delicate, shaped by physics so quiet it can only be understood slowly. Understanding the beads also deepens our thoughts about human exploration. If future astronauts melt them for water, they will quite literally be drinking the moon's most ancient stored memories. Imagine holding a vial of moisture released from a bead that formed billions of years ago, water-borne in an impact plume before mammals existed on Earth. The idea feels reverent, almost sacred, as though explorers would share a quiet communion with time itself. There is also a possibility that beads from different regions of the moon preserve different records, depending on their age, formation environment, and exposure conditions. This makes future sample return missions particularly important. Each bead might hold a unique fragment of the lunar timeline, offering clues to local geology, solar wind variations, or volcanic history. To study them properly is to treat each one like a tiny museum, where the exhibits are invisible but immensely valuable. Their presence in permanently shadowed regions could also indicate that water-rich beads migrate, carried by impacts or rolling slowly down slopes over immense timescales. In darkness where temperatures plunge to near absolute zero, these beads could preserve their trapped water almost indefinitely. Searching for such beads may prove easier than harvesting ice deposits, making them a surprisingly practical long-term water source for lunar outposts. The beads also provide a compelling narrative about resilience. Despite forming from violent impacts and enduring billions of years of exposure, they remain intact, their contents sealed. They are the moon's way of preserving traces of past events without erasure, an archive written not in books or carvings but in transparent spheres scattered across its plains. This form of natural memory feels more profound precisely because it is unintentional. They even shift our understanding of how common water might be on airless bodies throughout the solar system. If solar wind interactions can produce water on the moon, then perhaps similar processes occur on Mercury, asteroids, or even certain moons of Mars. The beads teach us that moisture can arise in silence, in places without atmospheres, through simple and persistent cosmic chemistry. Water, it seems, is more patient and adaptable than we once believed. In their quiet way, the beads blur the line between lifelessness and possibility. Though they contain no organisms and form through purely physical processes, the stories they carry of water, gas trapping, cosmic cycles hint at environments where ingredients of life gather and endure. They are not signs of life, but they are signs that the universe preserves potential in unexpected places. These beads, scattered across the moon like tiny fossils of fire, remind us that even in stillness, a world can store immense complexity. Their simplicity masks their depth, just as the moon's barren appearance hides the layers of history tucked beneath its dust. When you imagine yourself holding one, feeling its smooth, ancient surface warmed slightly by the light of a distant sun, you may sense the hum of ages within it. And so, as we drift deeper into this quiet lunar tale, the glass beads become gentle companions, small, enduring, patient. They gleam softly in the dark, carrying stories that span nearly the entire history of the solar system. Their existence is a kind of comfort, a reminder that even in the vast silence of space, memories accumulate, preserved in the tiniest forms. If the moon has ever tried to speak, these beads may be the closest thing it has to a voice, not loud, not direct, but enduring. And as we lean in with slow, sleepy breath, we realize that their whispers are enough.